Guys, welcome to class today. If you are new to this channel, subscribe to Ultimate Mathematics. Okay, let's proceed. We have a question on operational research. That's an aspect on simplex method. Let's quickly dive inside. Okay, they say we should maximize P, which is equal to 5x plus 4y, subject to the constraint 3x plus 5y less or equal to 78 and 4x plus y less or equal to 68. So what's actually going to happen is that this P here is what we call the objective function. Objective function. Then these two equations that I've circled are what we call the constraints. Okay, so this objective function can also be the major function, and this constraint can also be the minor functions or minor equations. Okay, to proceed, what we're actually going to do here is that we are going to introduce stack variables. And introducing stack variables could be any letter of your choice. It can be letter, it could be letter number. That means a number and a letter. So let me say, I would rewrite these equations, especially the constraints, and I'm actually going to do what? I'm actually going to introduce a stack variable. So before I do that, before I equate them adding my constraint. What I should do is that let me take the constraint first. So I have 3x here plus 5y less or equal to 78. I'm rewriting them. Then I have my 4x here plus my y here less or equal to 36. So introducing my constraint, I'm using S1 here and I'm using my S2 here. That is the various constraints I have introduced. Then the objective function, I'm also going to write the objective function, but I'm also going to equate it to what? 0. So I have my P here minus my 5x minus my 4y, which should be equal to 0. So I come and write this S1 plus my 3x here plus my 5y here equals 78. Then I have my S2 here plus my 4x here plus my y here, which should be equal to what? 36. Then my objective function will be a tantamount to P minus 5x minus 4y, which is what? Equal to 0. So after I've done this, what actually I'm going to do is I'm going to create a tableau. So I have my x here, my y here, my S1, my S2, my P. The reason why we create the tableau is that we're actually representing the coefficients of the various variables that we have. So from here you see that the coefficient of S here will be what? Will be 1. The coefficient of what? The coefficient of x here will be what? 3. The coefficient of y here will be what? 5. Then we have the equatant, the result, which is what? 78, 0, 0 here. This one, we don't have any of them there. So then what I'm actually going to do, I have my 4 here, my 1 here. I'm writing their coefficients, my 1, my 0 here. Then I have my 36. Here I have 0, my P1. Then I have 0, I have 0, I have minus 4, I have minus 5. Okay, there is a problem here that students face a lot in order to proceed. Sometimes most people think that you can only find your pivot element at this column, which is very wrong. What you actually do is that to locate where actually you are going to find your pivot element is that you first look at the highest negative value you have for the coefficient of what? The objective function. Or someone will say find the smallest number, and from here the smallest number is what? Minus 5, and the most negative number is also what? Minus 5. So indirectly we have gotten a clue that our pivot element can be located in this column. So what then do? We then take the the equatant, that's what the equal to what is actually tantamount to the various equations, and we strike them. So our ratios now here is that we are actually going to get our 78 divided this one here divided by this the 3. Then we're also going to get our 36 divided by 4. So 78 divided by, we have our 26, we have here to be 9. So after this, what we are going to do is that we take the smallest ratio, then we trace it. So the smallest ratio is gotten from 36 divided by 4, which is 9. So we trace it here and we pick this as our pivot element. So our pivot element here is now equal to what? 4. I'm actually going over it chronologically so that you understand. Okay, so what I'm actually going to do is I'm going to find equations that are actually going to make this pivot element I found here 1, and make whatever is above it or below it 0. So what equations do you think is going to be very, very important? So the equations that I should be thinking of is what? I should be having my R2, which should be equal to what? 1 over 4 R2. And also for my equation 1, I should be having R1 minus 3 R2. And for my equation 3, I should be having my R3 plus 5 R2. Okay, after we have gotten this, then we draw the tableau and use this equation to manipulate the coefficient. So I have my x here, I have my y here, I have my s1 here, I have my s2 here, I have my p here. Okay, then I also have yes, I have them all. So what I'm actually going to do is there, I'm going to manipulate the R2 here. That's the row 2. The row 2. So if I should manipulate the row 2, I'm going to get a 1 here, a 1 over 4 here. Then I'm going to get a 0 here. I'm going to get a 1 over 4 here. Then I'm going to get a 0 here and a 9 here. What actually occurred here is that when I take the equation, some will not understand what I'm doing, but when I take the equation I've gotten here, my R2, which is equal to what? 1 over 4 R2, it implies that when I should take this one here, this 4 here, is actually going to be 1 over 4 times 4, which is equal to what? 4 over 4, which will give me what? A 1. Yes, I know you are with me, so let's go. So then if I should manipulate row 1 with this formula, I'm also going to get 0 here, 17 over 4, then a 0 here. Sorry, here will be 1. Sorry, I'm very fast. Okay, then 3 over 4. Then here I'm also going to get 0, then a 51 here. So finally, for the row 3, this formula is going to make me get my 0 here, minus 11 over 4, 0 here, 5 over 4, 1 here, and 45. So after I've gotten this value here, I am done with what? What I'm supposed to do here, I'm done with that. So now I need to look at the coefficient of the objective functions, that area, and check whether still I have a negative. If I have a negative, then I need to proceed. Okay, so I have a negative 11 over 4. So what I'm actually going to do here is that since I have a negative 11 over 4, then I'm going to pick this one here. Then I'm going to do something about it so that I'm going to get what? A positive value here, because the whole idea or the whole concept of this simplex method is that we're actually making the below the tableau, we're actually making it so that we get either zeros or only positive values. So let us go. So now I'm finding their ratios again. So now I'll be having a 51 here. This 51 now divided by 17 over 4. Then 9 divided by 1 over 4. So I have my 51 here divided by my 17 over 4, which will give me 12. Then here too, another ratio is if I should divide my 9 by my 1 over 4, I'll be getting a 36. So now I'm going to choose the least value this one, which is actually going to give me what? It's going to show me my pivot element. So this is what I'm dealing with. So indirectly, it means that my pivot element now is what? My pivot element here is now equal to 17 over 4. So I'm going to look for equations that are going to make this 17 over 4 here to be 0 and to be 1, then everything below it here being 0. So now, okay, a few seconds, think about it. Okay, my R1 is actually going to be, this equation is actually going to help me 4 over 17 R1. Then my R2, this equation is going to actually help me R2 minus 1 over 4 R1. Okay, and my R3 is actually going to be, okay, R3 plus 11 over 4 R1. Okay, so now after doing this, I'll then draw my tabular here, XY, S1, S2, P. So if I should take my R1, my R1 says that is 4 over what? 17 R1. So 4 over 17 of what? R1. Which directly is going to give me what? 0. So that's what I'm actually going to do here. So by manipulating the whole row 1 here with this formula, with this formula, that's the 4 over 17 R1, I should be getting 0, 1, 4 over 17 minus 3 over 17, 0, and 12 here. Then if I should take my row 2 to R2 minus 1 over 4 R1, R2 minus 1 over 4 R1. So now, here is my here is what? R2. So here is my R2 here. My R2 is probably 1. My R2 is 1 minus 1 over 4. Then my R1, I'll pick it from this table, which is what? 0. So I'm actually going to get a 1 here, manipulating the various values again. I'm going to get 1 here, 0 here, minus 1 over 17, 5 over 17, 1, then 6. Okay, manipulating with this third formula here for the row 3, I'm actually going to make a 0, 11 over 17. And I'm also going to make a 13 over 17. And I'm going to make a 1 here and a 78 here. Okay, good. Now we are done. We have made everything here to be either zeros or positive. But not just by doing that, by following the required formulae. Because there are a lot of formulas. So we call them formulae. Okay, so we are maximizing P. The final answer here is that our P. So we now check for our X and our Y. This is what mostly confuse students. What you're actually going to do here is that you see that you have, don't ever think that always your first row is your X, never. But we look at where the ones fall. You see that there is 1 here. The 1 is what? Under the Y. So our Y, when we trace, is what? 12. Then our X, you see the 1 here, when we trace is what? 6. So let's do something here. Let's take the objective function here, which is what? Our P equals 5x plus 4y. So which is equal to our 5, our X is 6, plus our 4y, which is our Y is 12. So 5 times 6 will give us 30 here. Then 12 times 4 will give us 48. So if we should add this two, we are getting what? Our 78. So if I say our P, max P, is 78. There is no doubt about it. Okay, thank you very much. And don't forget, the head is always big for a reason. Always subscribe to Ultimate Mathematics Frederick. Till we meet again, adios. Bye.